So here we are going to discuss number 6. It says if the second term of a geometric sequence is 12 or geometric progression is 12 and the fifth term is 324, which term has the value of 8,748? Okay, so therefore now we have two pieces of information that will give you. So two equations can be formed. Now, since this is a geometric sequence and they spoke of the second and fifth term, hence we must use the nth term formula for a geometric sequence or geometric progression. So it continues by saying that the formula for the nth term of a geometric progression is a sub n is equal to a plus r raised to the n minus 1. The a by itself is the first term, r is the common ratio, and n is the term number. This formula calculates any term in a geometric sequence by multiplying the first term by the common ratio raised to the exponent of 1 less than the term's position. So in order to find which term has 8,748, which position does 8,748 occupies, we need to use this formula, but we need to know what is A and R. That's two variables, two unknowns. So this is why two information is given so that we can have simultaneous equation and solve for E and R. And then we can find the N for 8,748. So before we move on to find E and R for that particular question, let us go through the formula breakdown. So A sub n is the nth term you want to find. A is by itself is the first term of the sequence, and R is the common ratio, which is formed by dividing any term by its preceding term. So R is equal to A2 divided by A1. And N now is the position of the term in the sequence. So here we have an example. It says to find the fifth term of a geometric progression with a first term E of 3 and a common ratio R of 2, you would use the formula A sub 5, because you want to find what value is the fifth term, which value occupies the position of 5. So that is 3 times 2 raised to the exponent of 5 minus 1. 3 times 2 raised to the exponent of 4. We must find the exponent of 4 first before we multiply. 2 to the exponent of 4 is 16. So 3 times 16 gives us 48. So 48 occupies the fifth position in this example. Now in our situation, we do not have A and R, but we know what is the second term. The second term is 12. Okay? So therefore now we can, and n is 2. So we can substitute 2 in the place of n and 12 in the place of the A sub n. And we have 12 is equal to A R raised to the 2 minus 1. 2 minus 1 is 1. So 12 is equal to AR. So this is equation 1. And we can make another equation with the fifth term is 324. Substitute 324 in the nth term. A sub 5 is 324. N will be 5. So we have 324 is equal to AR raised to the 5 minus 1. So therefore 5 minus 1 is 4. So we have 324 is equal to AR raised to the 4. So we've got two equations and two unknowns. We can solve for both unknowns. Since A and R raised to the 4 are multiplying respectively, we can divide the equation, divide them by themselves to cancel out A. A divided by A is 1. Okay? And it says so here. Since we now have two equations, we can solve for A and R. Which we said already, we can eliminate A by dividing the bigger equation by the smaller one. So the bigger one is 324 AR to the 4. It goes on top and comes below is 12 is equal to A sub R. 324 divided by 12 is 27. A divided by A cancels out. And R to the 4 divided by R raised to the 1 you just subtract the exponents. That will be 4 minus 1 because you are dividing. When you dividing, you subtract the indices. So therefore, 27 is equal to AR to the 3. To cancel out 3, we cube root 27 and R is equal to 3. So now we have R. We can solve for A now. Okay, so to cube root in your calculator, you have to use the cube root button, or you can raise up 27 to a third, okay? Because this is 27 raised to the 1 below there. And the value now of the root is 3. So this can also be written as 27 raised to the power of a third, okay? And if you do that in your calculator, you also get 3 for R. Now we can use any of the equation to solve for A. Here we chose 12 is equal to A times R. R is 3. So 12 is equal to A times 3. You divide by 3. And then we have 12 divided by 3 is 4. A is equal to 4. So now we're in a position now to complete that nth term formula for that particular situation. So A sub n is equal to 4 times 3 raised to the n minus 1. Okay, because A is equal to 4 and R is equal to 3. So now we can solve for the position that 8,748 occupies. So it says, which term has value of 8,748? Here we have the term value. We want to find the term number. Therefore, we put 8,748 in the nth term position, and we are going to try to solve for n. We divide by 4 in order to apply logarithms because n now is part of the exponent. And we came across the power rule for the exponent already. You take logs on both sides, and the power now, or the exponent, can be written as a multiplication. Okay? So that's what was done here. We find logs on both sides. Okay, so log of 2,187 is equal to log of 3 raised to the n minus 1, and then n minus 1 on a whole, in a bracket, comes as a multiplication to log of 3. So now we can divide by log of 3 on both sides. That's log to the base of 10. If you don't see a base, there's an invisible base of 10. Okay, so that, and which of course is programmed in a scientific calculator. And you just find log of 2,187 divided by log of 3. So we get 7. See if you get 7. And then we add 1 on both sides. So n is equal to 7 plus 1. So n is equal to 8.